Okay, so the recording has begun. This is day number 4, week 2 of our journey together. And it's definitely a delight to have each and every one of you here this evening. We're going to begin as where we always begin with math. So today is Thursday, the 8th of September, and it's 2022. The subject, of course, is mathematics. Like my statistics teacher has told me in the past, math is easy. Don't make it hard. And that's my advice that I give to you as well. It's not a difficult subject. It can be made difficult though. So you have to practice. You have to study, go over the things that I share with you so that you could be able to do well in the subject. Okay, so the theme, of course, is mathematical concepts. And I want us to begin by looking at section 1. So section 1 is entitled Average Speed. And for this section, I want us to look at some prerequisite information before we actually dive into the actual questions. Okay? Prerequisite information. All right. All right, so the prerequisite information that we'll be looking at tonight is, the first thing is the speed formula, or you say your average speed formula. Wait, say, yeah, let me just, yeah, average speed. So the formula for average speed, anyone know the formula for average speed? If you ever did it before? Average speed. The screen is very small. You sure?
Distance divided by time.
Distance divided by time. Total distance over total time, yes. So the average speed, she said this, the words are small, so let me enlarge it. So average speed is going to be equal to total distance divided by total time. That's the formula for average speed. So total distance over total time. Now, now when we look at something like this, there is a triangle. We call it the average speed triangle, and you know this triangle is very helpful. So the way how this triangle works is that, so we have this triangle here, and it's going to help us to know how to get the formulas for the different parts of this equation. So we know that speed, or average speed, all right, speed is equal to, so average speed is going to be equal to distance over time. So speed equals distance over time. So again, speed equals the distance divided by time. So distance divided by time. What if we want to know what is time? How would we figure what time is?
Distance divided by speed.
Very good. So time is going to be distance divided by speed. So speed is distance over time, and time is distance over speed. right? So let's write that down. So time taken is going to be equal to, like we said, this distance over speed. Excuse me. So this is distance over speed. So speed equals to distance over time. Time equals to distance over speed. What is distance? What is distance? What's the formula for distance?
Speed times time.
Someone said speed times time. Do we agree with that? That
Yes,
distance
sir.
is speed times time. Anyone agree? Do we agree with that?
Yes, sir.
Yes, most definitely. So distance is going to be equal to speed multiplied by time. So distance is speed times time. So again, speed equals distance over time. Time equals distance over speed. And distance equals the speed times time. So this triangle is going to help you to answer it. Again, speed equals to distance over time. Time is equal to distance over speed. And distance is equal to speed times time. Okay, so let's make a note of that. So distance equals to so distance is gonna be equal to, oh, not that, it's multiplication. So distance equals to speed multiplied by time. So distance is speed times time. So that's the formulas that we need when it comes to this particular topic. We need to know what is average speed. We need to know how we're going to get the time taken, and we need to know how to get the distance. Those are three important formulas when we're dealing with average speed questions. How are we going to get the average speed? How are we going to get the time taken? And how are we going to get the distance traveled? Say it again. Say it
You
eight.
asking me?
No. I'm not asking. I'm just saying. We're just talking about the formula. I haven't asked the question yet. Okay. So we know I can move from this, please.
I'm finished.
Okay, you finish? All right, good. So let's do it. So you're gonna look at an example. And our example involves a power boat. So power boat. Well, really a speed boat. So let's get a picture of that and put that um on our put that on our question. So we're gonna be there with speedboat with child. Okay, good. All right, so we have our speedboat there. Anyone ever ride in a speedboat before? Anyone
No,
ever
sir.
anyone ever rode in a
Yes,
speedboat before? Who said yes? Hmm.
me.
All right. Okay, interesting. All right. So example one. So example. So let's consider this example here. So so it says, if I could go over so you can see it properly. All right. So it says a powerboat in a Formula One, Formula Two race has an average speed of 165 kilometers per hour. Now, that's the average speed that this boat is moving with, right? So the question now is, we know that. Question now is calculate A, the distance in kilometers that the boat traveled in a race of 1 and 2/3 1 and 2/3 hours. That's the first question. And the second question says calculate the time in minutes to travel a lap of 5.5 kilometers. Right, so these are some interesting um, questions. So let's continue. Let's look at them one by one. So we're going to first deal with question A. And question A says that we want to figure out what is the distance in kilometers that the boat traveled. So let's begin with answer A. So for answer A, we want the distance traveled. So distance, according to the formula, what is distance? Anyone remember? According to the formula, how do we find distance?
Speed times
Distance is going to be speed multiplied by time. Okay, so we have to take the speed. From this question, what is the speed? What is the speed?
165 kilometers per hour.
Very good, 155 kilometers per hour. That's the speed. So distance is equal to speed multiplied by time. So the distance, so the speed is going to be 165 kilometers per hour. So that's 165 kilometers per hour. And that's going to be multiplied by time. So time, this is 1 and 2 over 3 hours. So this is 1 and 2 over 3 hours. Now, the trick with this one is 165. We can write that as, how can we write 165 as a fraction?
Put it over 1.
Put it over 1. Very good, Zion. So we're going to take 165 and represent as a fraction and put it over 1. So it's going to be equal to 165 divided by 1. Now we multiply. But before we multiply, we're going to take this fraction, this mixed number rather, and change it into a improper fraction. So we have 1 and 2 over 3. Tell me, is Rosaria Bennett there? Rosaria Bennett, is she there? No, I don't see her. Anyone knows how to take this fraction and change it into a mixed number?
Yes, so you have to add 3 plus 1, and then you have to multiply 4 by the 2.
Not quite. Close though. Anyone want to help her?
You times the denominator by the whole number and add it to the numerator on top, and then put it over the denominator.
Excellent. Very good, Zion. Very good. So is Shazmin Butler here? It's okay. This one. All right. So, well, first thing we do is we multiply the 3 by the 1. And what is 3 times 1?
3.
3 times 1 is 3. Plus 2?
5.
5. So this is 5 over 3. So again, we multiply the 3 by the 1 to give us 3. And then we add 2. 3 plus 2 is 5, and then we just keep the denominator. One more time, we multiply the 3 by the 1, that gives us 3. Add 2, that gives us 5. So this is 5 over 3. All right, so we have 5 over 3. Now, go ahead. Go ahead, some other question.
Multiply times 1, and then we add 3 plus 2.
So we multiply the 3 by the 1, that gives us 3, and we add 2, which gives us 5. Okay, that's how we get
Okay.
that. All right, so this is going to be equal to 5 over 3. So at this point, what we need to do is we need to multiply 165 by 5. What is 165 multiplied by 5? We get 5 times 5, which is 25. We bring down the 5. We bring up the 2. What is 5 times 6?
30.
30. 30 plus 2 is what?
32.
32. Then we have 5 times 1. What is 5 times 1?
5.
5 plus 3?
8.
8. So this is 825. So we multiply the 165 by the 5. We multiply the 1 by the 3. What is 1 times 3?
3.
3. And then the last step that we do is we divide 3 by 825. So how much times 3 goes into 825? So 3. So I'm going to put it here. 3 so it's 3 divided by 825. Good. How much times 3 goes into 2? So how much times 3 goes into 8?
2 times.
2 times. 3 times 2 is 6. What is 8 minus 6?
2.
8 minus 6 is 2. Very good. We bring down the 2. How much times 3 goes into 22? That should be 7 times. 3 times 7 is 21. 22 divided by 21 is 1. Bring down the 5, that's what?
15.
15. So how much times 3 goes into 15? That's what?
5 times.
5 times. So this is what? This is going to be 15. 15 minus 15 is 0. So the answer here is most definitely 275. They say they want the answers in kilometers. So it's 265 kilometers. Alright, alright. Alright, so that's how we get our answer of 100 of, well, let me write it there, 265, 275, instead of writing it on the side there, 275 kilometers. Alright, so let's recap, quick recap. The question asks us to find the distance. So we know that the average speed from the question, we know the average speed is 165 kilometers per hour. We know that the time it takes to travel is 1 and 2/3 hours. And so the question is, what is the distance? Well, distance equals speed multiplied by time. The speed that we have is 165 kilometers per hour, and the time that we have is 1 and 2/3 hour. In order to convert this number into a fraction, we divide by 1, and we have to take this mixed number and convert it into a improper fraction by multiplying 3 by 1 and adding that by 2. So we get 5/3. So we have 165 over 1 multiplied by 5/3.
I don't understand that.
Say it again.
I don't understand none of that.
You don't understand none of this? What part do you don't understand?
Everything.
Okay, you understand the formula that distance equals speed times time.
Yes, sir.
So we got that from here. That's the formula that I gave y'all. Alright? Okay, now what is the speed, Jasmine? According to the question.
106 kilometers.
165, right? What is the time it takes?
1 and 2 over 3 hours.
Good. So what we have to do with 165 and 1 and 2 over 3?
Multiply.
Multiply them. Very good. Now, in order to take a number and represent it as a fraction, what must we do? So if I have 5 and I want to represent it as a fraction, how can I make that a fraction? What if I just put it over 1? So 5 is a fraction as 5 over 1. 10 is a fraction as 10 over 1. And 8 is a fraction as 8 over 1. So the reason why we put this over 1 is because we're trying to change it into a fraction. Do you understand that part, Jasmine? Okay, now, do you understand how we change this into a improper fraction?
No.
No, okay. That's the part. Okay. So the first thing we do is we multiply the bottom number by the whole number. What is 3 times 1, Jasmine?
3.
Good. Add 2.
5.
5. So we have 5 over 3, right?
Yeah.
Good. Because we don't change the bottom. Okay? So we have 5 over 3. What is 5 times 165, Jasmine? What is 5 times 165?
825.
Very good. 825. What is 1 times 3?
3.
3. Very good. Excuse me. And what are we going to do with 825 and 3?
Divide
Divide them.
3 by 825.
So when we divide them, what do we get?
275.
Very good. And so that's how we get the distance. Okay.
Okay.
All right. Anybody else have any questions for me? Okay, so let's do another one. The next thing they ask us for is time in minutes. I'm not gonna do the time one because that can take forever. I just want to explain this one again. Okay, so let's do another example with just the distance for now. And I guess that maybe the next section we could look at the time. So this is the distance, and let's look at another question involving distance. So intro. Okay, so this is another example.
You have to write this down.
Yes, mom.
Okay.
Yes, forgot. Yes, whatever I put on the screen is for you to write down. Thank you for reminding me to say that. So what you're doing is you have in front of you a pencil or pen, and you're taking down the notes that I provide, all of the examples and um, all of the examples and all of the questions. Okay, so that you can have as your reference, so that when you are reviewing for your exam, you can know. Okay, all right. Okay, we covered average speed. Okay, um we did linear equations. Okay, we did order of operations, and then you could be easy to have something to reference by when it's time to study. All right, it's a nice speedboat, right? Nice red speedboat. So let's go again with the speedboat question. All right, so let me zoom it in. All right, one moment. So we have Alright, so the question reads as follows. A powerboat in a Formula 2 race has an average speed of an average speed of 174 kilometers per hour. Calculate A, the distance, in kilometers that the boat traveled in a race of 1 and 2/3 hours. Alright, so let's do this one. Alright, so for this question, what's the first thing we're gonna do? What's the first thing that we're gonna do? Anyone have any idea? What's the first thing that we're gonna do? Come on, all you been high and dry. Okay, let me call names.
Write down how to find the distance.
Very good. Write down our formula. Amia, what is the formula for distance?
Speed times time.
Very good. Distance equals speed times time. So distance is going to be equal to, based on the formula that's given, distance equals speed times time. All right, Chris Raming, are you there? Chris Raming, are you there?
Yes, sir.
Okay, good. What's the speed? Based on the question, what's the speed?
Um, 174.
Very good. The speed is 174 kilometers per hour. Serenity, are you there? Serenity, are you there? I'm not able to hear from Serenity. Renshawn Rule, are you there? Okay. How about Michaela? Michaela, are you there? Okay, not hearing from them either. Matthew, are you here?
Yes, sir.
Okay, what's the time?
Pardon me?
What's the time? in this question? Say it again. What's the time? I guess he's trying to speak, but he can't say it.
1 2/3.
Yeah, 1 and 2/3. Very good. So 1 and 2 over 3 hours. And Sean, why is the screen black? I guess you have to log out and come back in if that's the case. So we have 1 and 2 over 3 is going to be equal to Cesaria. Are you there? Cesaria Ferguson, are you there?
Yes, sir.
Okay, good. How do we change the fraction into how do we change the whole number to a fraction?
Um,
What do we do with this 174? How do you write it as a fraction?
I'm not sure.
Are you there for our first example?
No, sir. I just came.
Oh, you just came. Okay. Otessa Albury, are you here? Okay, I'm gonna from Otessa. Okay, how do we change this 174 into a fraction?
You put it over 1.
74.
Very good. 174 over 1. So it's gonna be 174 over 1. Good. And then what do we do? Shazmin, Butler, what do we do to 1 and 2 over 3?
You time. Hold on. You times 1 times. Oh, yeah, times 1 times 3 and add 1 plus 2. I don't know.
Okay. So for this one, in order to find the in order to change it into a mixed number, we are going to, let me show you exactly what we do. We multiply the 3 and the 1,
and then add the 2 on top.
and then add the 2. Very good. Then add 2. So we multiply 3 and 1, then we add 2. And we keep the denominator. So what is 3 times 1? That's 3. Plus 2 is 5 over 3. And so this is going to be here 5 over 3. Good. Deja, what is 174 times 5? 174.
I didn't do that way. I canceled.
You cancel out? Okay.
Yeah, I canceled 3 and 174.
Okay. So that's the way to do it. 174 times 5 is 870. So let me just show you. So 174 multiplied by 5. We know that 5 times 4 is 20. Put the 2 down. Sorry, put the 0 down. Put the 2 up. We know that 5 times 7. But 5 times 7 is definitely 35 plus 2 is 39. No. 5 times 7 is 35 plus 2 is 37. No, 39. 5 times 1 is 5 plus 3 is 8. So the answer is 870, and then we divide. What is 1 times 3? Frank Pong? 1 times 3?
3.
3. Very good. And what are we going to do next, Gustav?
You're going to divide 870 into 3.
Very good. 870 divided by 3. Anyone got the answer yet for 870 divided by 3?
290.
Say it again.
290.
290. Very good. So 3 goes into 8 once. No, twice. 3 times 2 is 6. 8 minus 6 is 2. Right under 7. 3 goes into 7. 27. 9 times. So it's going to be 27. And 27 minus 27 is going to be 0. Now, next we bring down the 0. How much times 3 goes into 0? 0 times. 0 minus 0 is 0. And so the answer here is going to be 290 seconds, minutes, or kilometers?
Kilometers.
Kilometers, very good. Alright, and so that's how we would do a question like that. So what did we do? Well, the first thing we did was we write our distance formula. Distance equals speed times time. Then the next thing that we do is we take the distance, sorry, we take the speed that they give us in the question, we multiply that by the time that we have. We take 174 and put it over 1 because we want it as a fraction. And we convert 1 and 2 over 3 by 5 over 3. Shasmin Butler, you understand how we converted the 1 and 2 over 3 to 5 over 3? Or want me to explain that again?
I didn't get it.
Okay, good. Let me say 5 times 174, which is 870. And 1 times 3 is 3. Okay? And so that's how we tackle that particular question. Any questions on this?
No.
Okay, good. So we ready for exercise? So we need another example. We need another example, or are we ready for the exercises?
We ready for the
I'm ready for the
exercise.
exercise.
Are we ready for exercise? Okay, let's go. Yes, sir. Hello. Yes, sir. I don't see you in the class. Okay. Okay. How about your brother? Okay. All right, no problem. All right. Okay, exercise number 1. This is average speed. I only need to give y'all 2. This is going to be the first one. Both of them involving the same equipment, powerboat. These are some very pretty powerboats. They look class. Let's pick this one. All right. All right. No, they don't want to show up. Okay, let's do the next one. Since I want to show up. Okay. All right, good. Ooh, that's pretty. All right, so put that on that side, and let's begin. So So a powerboat in a Formula 2 race has an average speed of 183 kilometers per hour. Calculate A, the distance traveled, sorry. How many persons in there have a geometry set?
I have a geometry set.
I do.
Raise your hand if you have a
I
geometry
do.
set. Let me see you all have one. Yes. Okay. Okay. All right. That's 9. 9 out of 25. Only 9 if you have geometry sets. Okay. I want to start using that geometry set. So next week, we're gonna begin using that geometry set. Please make sure that you have it on you, like for class, all right? Because we're gonna start using the geometry set with construction, all right? So make sure you actually have your geometry set on you for next week class, all right?
Okay.
All right. So the distance in kilometers
Okay.
that the boat traveled in a race of 1 and 2 over 3 1 and 2 over 3 hours. Number 2, a powerboat in a Formula race. Formula 2 has an average speed of 192 kilometers per hour. Calculate A, the distance in kilometers that the boat traveled in a race of 1 and 2 over 3 hours. Alright, so I'm gonna put the screen larger, and I'm gonna give you 3 minutes to complete this. Alright, okay, great. The time has begun. You have 3 minutes. So the question says a powerboat in Formula 2 race has an average speed of 183 kilometers per hour. Calculate the distance in kilometers that the boat traveled in a race of 1 and 2/3 hours. The second question, very similar to the first, a boat in a Formula 2 race has an average speed of 192 kilometers per hour. Calculate the distance in kilometers that the boat traveled in 1 and 2/3 hours. Right, so that is your question. I want that once you're finished with the question, to please put your answer inside the chat. Again, once you're finished with the question, please place the answer inside the chat. I want everyone answering, please. If you do not understand something, please let me know so that we can explain it for you. All right, remember once you finish, put your answer inside the chat. Sion, thank you so much. Something from Rakia. I got something from Otessa, Aubrey, and Miss Neely. All right, that's time. That's time. Chris Rame, I got something from him. Bino, got something from him. Sion. Saria, did you get that? Saria, do you understand what's happening?
Yes, sir.
Okay, I got something from him. Shasmin, Butler, Miss Confidence.
I just put it in the chat.
Okay, just put it in. Serenity. Serenity, are you there? I don't know, but I never hear from Serenity, like, ever. That's interesting. So I really need to check up on Serenity to see what's happening. Like the person always come but never responds. I'm like, okay, that's weird. Okay. All right. Rosario, do you understand what's happening? Rosaria Bennett.
Yes, sir, but I'm late today.
You late today? What's happening? I know you're the early bird.
I fell asleep.
Oh wow. Good child. Okay. For Sean. Who else we looking for? Rakia. Rakia Roll.
Yes.
I don't see your answer. Did you post anything? Oh, I just saw it. Yeah. Okay. Otessa Albury. Do you understand what's happening? Otessa, do you understand what's happening? I'm not hearing from Otessa, but I think I see her answer. I think I saw her answer. Yeah, okay, yes, sir. Natalia. Natalia, are you there?
Yes, sir. I'm not finished yet.
Okay. Michaela Maki.
Yes, sir.
Did you post anything in the chat yet?
No, sir.
You understand what's happening?
Mm-hmm.
Okay, that's good. Who else I haven't seen? Jensen, Bethel, all is well?
Yes, sir.
Did you post anything in the chat yet?
Oh, he's doing finish.
It's on finish, okay. Frimpong, Tantanka. What happened to Frimpong? Frimpong, are you there? Osafo? Osafo, I was there. What happened to Osafo today? Thank you, Angela Penniman. I'm not hearing from Osafo. And Sean, we got there for him. Yeah, basically everybody except for Diamond. Diamond, are you there? Diamond? Okay, I didn't hear from Diamond. Okay, concerning Diamond. Hello, Diamond, are you there? No.
Yes, I am.
Okay. I didn't see anything from you in the chat.
I sent my answers.
Are you saying it? Okay, good. Amaya, I'm Bristol.
Yes, sir. I posed my second answer just now.
Okay, it doesn't make sense to you, or you struggling with it.
It's fine. It's a little long answer, but I got it.
You got it. Okay, good. All right. Chris Ramming. Chris Ramming.
Yes, sir.
Do you understand what's happening?
Yes, sir.
Okay, that's good. All right. So basically, the only person we haven't heard from is Serenity, which we never hear from anyway. But all right. So Amia, Altonique, Angela, Zaria, Otessa, Jazaria, Renshawn, Frimpong, Kantanga, Amia, Matthew, Chris, Diamond, Shazman. How confident are you in your answers today?
I'm very confident. All of them right.
All them right. All right, as usual. Okay, all right then. Zaria, Bino, Chris Ramming, Deja, Neely, Otessa, Rakia, and Zion. Zion, how you finish so fast, man? I don't know how do you get them so fast, Zion? You need to teach me the trick.
He probably will calculate or something.
She probably use calculator. Well, you could use calculator. Nothing wrong with that, but
I'm allowed to use calculator.
golly, she's got them fast. That's pretty neat. I need to know the hack. What is the hack to this?
I already is right fast, so
Say it again. You already?
it's right fast.
Oh,
So
you already
it's
is right fast. So it. Okay. And you think fast too, so that's good. All right, so
He probably the fly from the movie.
she's a. Oh my goodness, ping pong. That's so still. Wow. My goodness. Oh. Oh boy. Oh my goodness. You try it though. Oh my goodness. If you don't laugh, you could cry. Ping pong, I was trying to get your attention earlier. Where were you? Hey, ping pong. And then he disappears. Oh boy. All right. Okay, so how do we do distance? So the first thing we do is we obviously we do the distance. We apply the distance formula. So distance is going to be equal to speed multiplied by time, like we said earlier. And then we get the speed, which is 183 kilometers. Because of time, I'm just going to put it over one time. And then we know that 1 and 2 over 3, we know that that is 5 over 3. And that's going to be equal to, if we multiply 5 times 183 and then divide it by 3, we get 305 kilometers. So 183 multiplied by 5 is 915, and divided by 3, we get 305 kilometers. That's correct. And then we do this one. This is the second one. So we know distance again. It's going to be equal to speed. Rosaria, were you able to post any answers?
No. Yes, sir, I did this in physics.
Okay, you did it in physics, yes. Yes. And physics, that's true. We do this in physics. Alright, so we have speed times time. That's gonna be equal to, but the speed is 192 divided by, put it over one time, and then we do 1 and 2 over 3. If we change that into a proper fraction one time, it's what, 5 over 3. So it's going to be equal to what is 192 times 5? 192 times 5 is 960 divided by 3, we get 320. So this is going to be 320 kilometers. Now remember, once you're done with your mark notes, please take a picture of them and send them to me via WhatsApp. My WhatsApp number is 426-8891. Did anyone get 2 out of 2? All right. Let me know.
Me.
Okay. That's excellent. A lot of y'all got that. That's good. All right. So
I get it.
you got it. Very good. Amia, raise her hand. Do you have a question, Amia? Or you just raised it the signal that you also got?
Yeah, I just mean I get it.
Oh, you got it. Interesting. Wow. Wow, this is
Like interested.
Oh wow. You know exactly why it's interesting.
Hey.
Oh boy. Okay, good. That's good news. Now that's good news. That's great news. Okay. I guess we're doing something right. If Amia could get it, then okay, we know you're on the right track. All right. I want us to look at geometry. You know, we always gotta do some type of geometry, and I don't know if we did. I don't think we did much geometry this week, as far as my recollection could go. Let's see. Did we do much geometry this week? Let's see. Go back. No, okay, that's SAT. I talking about us. Okay, so yesterday we looked at, we looked at statistics, so that's mean measures of central tendency, order of operation. We did fractions that day. This is my other class. We did, yeah, we didn't really do geometry. Like, what are we doing? You hopped off some geometry. What? We didn't do no geometry this week? Okay. Alright, that's not good at all, child. Alright, geometry, here we go. Here we come. Let's go. We have to do some geometry. Geometry is always tested in any of your national exams. Geometry is always tested. They always test us on geometry. Geometry in some way. Alright? So we're gonna look at some questions regarding geometry. Something we haven't seen before as a class. So page 32. Alright, so let's look at it. Geometrical principles. Revisit it. So some of these principles you've probably seen the principles before. What I'm going to do today is I'm going to show you another example where we can have those principles being applied as well. Okay, so let's say we have, I want to look at this one. This one looks interesting. So let's look at this one. So, this is our geometry slide. So every time you see this, yes, with this one, okay, it's geometry time. Be prepared. So this one is an interesting law. So it goes something like this. So we have, all right. So this is it. I want to draw the big triangle first, and so let's make sure this is weighted. So we're gonna add some weight on this one. How many persons like geometry? You actually prefer geometry over the actual, the other type of math? Any geometry?
Me.
Who said me? I don't know your voices yet. Me, Matthew. Matthew said me.
Jazara Ferguson.
Jazara Ferguson. Okay. You actually like geometry. Okay, all right. Versus the other one. Okay, interesting. All right. How about you, Deja? What do you think?
Well, for some reason, my school did not really teach us much geometry. So,
All right. How about
I
this?
mean, I would say probably finding distance and trig better.
Okay. Okay. All right. That's good. That's trig ratios and all those good stuff. All right. How about you, Amia? Would you like you rather geometry, or I don't think you've ever done geometry in this class with me.
No, so.
Okay. All right.
Well, I haven't done geometry since, I don't think, maybe grade 10.
Okay. All right. How about you, Zion? Would you like geometry over the other math, or you like the other types, the other calculation types?
I don't like maths on the whole. I just do it.
But you're pretty good. You're pretty good.
I thought math is the easy stuff there.
Math is easy. Don't make it hard, right? Right,
I
Fringpong?
never said it was hard. I just don't like it.
She said she just don't like it. What subjects you like, or you prefer to do?
You probably like English.
I like my option classes.
I like my option.
What your option is?
Cosmetology for me.
Well,
Office procedures, accounts, and keyboarding.
keyboarding. Oh, you are a business girl. All right. So you actually like accounts?
Did he not? So yeah.
Okay, interesting. So you like to balance the sheets and everything.
Yeah.
Wow. That's amazing. Alright. So that's our shape. That's our shape. That's what we're looking at. Yeah, so let's continue. So this is the shape that we have. I want to just have too much on the box, so let's bring it in somewhere. Okay. This could go in some more. Yeah, that's more like it. And then we could bring this in some more. Yeah. Okay, good. How about you, Gustav? You like geometry or you prefer the other type of maths?
I love geometry. Me.
Wow. Okay, interesting. And so let's look at it. So we have these lines. Anyone can remember what these lines represent? That run through the triangle like this.
I think they're saying something, but it means it's equal.
What are equal?
The sides would have
Very
the
good.
front.
So they're saying that if we have these two, right, like so, this line like that, and this line like that, they're saying that this line along with this line, they are equal. And more than that, they're saying that their angles are equal. So this angle along with this angle is equal, which means if I want to be fair to the drawing or accurate to the drawing, I need to increase this some more. All right, that's probably better. Yeah, it's fairer to the drawing. So that means I increase this. Give me one moment, sorry. Okay. All right. That's okay. It's not perfect, but it's okay. I don't like how that form. Let me just keep it like how it was. It's basically the same thing. It's close enough. All right, so good. So we're saying that by this line and this line, we're saying that this line right here, this side of the triangle, is equal to this side of the triangle. They should be equal in length. All right. This also means that this angle here and this angle must also be equal. Even though they don't look equal, my drawing is wrong. But this angle and this angle must be equal in size. So what if we call this z, right? So let's call this z, and let's call this y, and let's call this x. All right. And then we're gonna call this one 53 degrees. All right. So we have everything labeled that we want labeled. Oh, one last thing. This is 27. This is 27 degrees. All right. So that is our shape. And so we want to figure out. Naturally, the question is going to ask, okay, what is x, what is y, and what is z? And so the question says calculate the size so our goal here is to calculate the size of, the first one is AI calculate the size of angle x, not B, but II calculate the size of angle y, and finally we want to calculate the size of angle z. Please leave space among them for you to actually write the answer. Alright, I think that's good enough. Alright, so I think we're ready. So with this one, okay, good. All right, no problem, Mr. Matthew. All right, so here we have angle x, right? So angle x is right here. Can anyone tell me how would they figure what is the value of angle x? Any ideas?
Say
Say it again. Any ideas on how are we going to figure out angle x?
I think you have to figure out angle y, and then I think it would be the same. I'm not sure.
Well, good, very good try, but remember they asked us for x first. So if they asked us for x first, that means that we could find angle x before finding angle y. Okay?
Can we add 27 plus 53 and then subtract it from 180?
Say it slower.
Can we add 27 plus 53 and subtract that from 180?
Why would you do that?
I have no idea. It's just the first thing came to my mind.
The first
But
thing
I know that would help me find the side.
that would help you find x?
I mean, yeah.
Yeah, maybe. All right, so remember that if we have a triangle, right? What do we know about the angles that are inside a triangle? The interior angles of a triangle. What are they gonna add up to? So angle A plus angle B plus angle C. If we have the interior angles of a triangle, what does that add up to?
I don't understand it because I just joined back because my Wi-Fi went out.
Okay, we just started. We ain't
Okay.
yeah. So I'm saying if we have a triangle, the inside of the triangle, these angles, what are they gonna equal to? The interior angles inside the triangle. Anyone know?
it's 180.
180 degrees. Very good, Miss Amelie and Deja. It's 180 degrees. Okay. So the inside of a triangle, all of these angles together gives us 180 degrees. So let's look at this. Here, right, look carefully. This right here, this is one side, this is two sides, this is three sides. What do we call this shape in yellow? What do we call the shape in yellow? Don't be shy. Come on, it has three sides. What is the name of that shape?
A triangle.
Very good, it's a triangle, right? So it's a triangle. What do we know about triangles in terms of their angles? The angles inside of them is going to add up to what? Matthew, are you there? Matthew? I'm not hearing from Matthew. Maybe Rosaria can help me. What do we know about the angles in a triangle? Rosaria Bennett?
180.
Okay, what about 180?
They all have to add up to 180.
All
Yeah, very good. They all add up to 180 degrees. So that means that 27, 53, and x, all of them together should add up to 180 degrees. All right? So if all of them should add up to 180 degrees, we already know that this is 53. We already know that this is 27. The only one that's missing is x. So to figure out what that is, we have to subtract 180 from 27 plus 53. And so to figure out what x is, x equals 180 degrees minus, so let me put this. So x equals to 180 degrees minus 27 degrees plus 53. Now, this means that x equals to 180 degrees. What is 27 plus 53? Let's add them. 27 plus 53. 7 plus 3 is 10. Put the 0 down. Put the 1 up. 5 plus 2 is 7. Plus 1 is 8, so that's 80. So 180 minus 1 minus 80. 180 minus 80 degrees is gonna be equal to, what is 180 minus 80?
0.
Say it again.
0.
0? 180?
Oh, sorry. 100.
100.
Yeah, 100.
Okay, good.
No, you say 180. That's 180.
Fine. That's fine. That's fine. All right, that's 100. Good. So x equals to 100. And the reason why that's the case, so let's put the reason. So the reason is because angles in a triangle add up to how much degrees?
180.
180 degrees. So this is gonna be like so. So that's the reason why that's the case. Alright, so next we move on to the second one. Now we want y. So x is equal to 100. So x here is equal to 100 degrees. That's what x is. X is 100 degrees. Let me make that clearer than that. So we know that x is equal to 100 degrees. Alright, so now we're trying to figure out what y is. Alright, any ideas as to how we're going to figure out what y is? And when x is 100, what is y? Any ideas?
100?
100? Why would it be 100? Rosaria, what do you think?
I don't understand it.
You don't understand it? Which one you don't understand? X or y?
X and Y. Like when you're trying to find the answers for that.
Okay, good. So think about it, Miss Gustave. we know that angles in a triangle must add up to what?
180.
180. We already know what 27 is. We already know what 53 is. We're trying to figure out what x is. So if we know that everything must add up to 180, all we need to do is add 27 and 53 and subtract it from 180 so that we can get what x is. Okay? And that's what we did. We add the 27 and the 53, and then we subtract our answer from 180 to give us 100. And 100 plus 27 plus 53 is 180 degrees. And so that's how we got x. Okay, because all of them together must add up to 180 degrees. Is that clear or no?
Yes, sir.
Okay, now y. We're trying to figure out what y is. Deja, how are we gonna get y?
Oh, that looks like a straight line. I could be wrong, but that looks like a straight line. When you put that green thing on top of the Y, so I guess we subtract 100 from 180.
100 from 180, 180, okay. Does anyone agree with that or no? She says subtract 180 from 100 from 180 to get y.
I said that because the green thing you have, like the green arch that you drew over the Y,
Yeah.
and when you connect that with the red one on over the X, that looks exactly like a straight angle.
Really?
Never mind. Maybe it's just my perspective.
Wouldn't y be 100?
Y would be 100. Okay, you say y is 100. Why would y be 100, Jensen?
They vertically opposite. I think.
They're vertically opposite. Okay, interesting. You said they're vertically opposite. Okay, interesting. All right, Zion, save the day. Save the day, Zion.
Me?
Yeah, you save the day.
I think it's 100 too.
You think it's 100 too? Okay, okay. Well, Miss Confidence, I know what to call Miss Confidence.
Man, I starting to feel weird. Everybody's saying 100.
Miss Confidence, where is she?
I read your listening.
You listening, man? You Miss Confidence. Save the day.
What? What happened?
Save the day, man. Save the day. We're trying to find why. Why would we find why?
I don't know.
What? Miss Confidence, what happened, man?
A little lost right now.
Lost now. All right. Okay. Bino. Martial arts king. Save the day for us. Bino.
I don't know either. I just sitting back.
You sitting back. Oh boy. Maybe who could help us now? Maybe Cesaria. I know Cesaria can help us. Cesaria.
So what do you want to?
Cesaria. She said have to be 100. Okay.
Me?
Yeah, you Cesaria. You. Save the day.
He's struggling mine. Know what you mean? I think 100 too.
She think 100 is about old child. All right. So let's look at it. If we have let me just show you all this rule so we can apply it. So the rule is that if we look carefully at, say, if we are given a line, so let's say we have this line right there, and let's draw another line. Let's say the line, we have another line looking like this, and we have another line looking like this, or so that this, or in our case something looking like this. Good, good, and good. Alright, so I think we're ready for this rule. Alright, so the rule tells us that someone is saying something. Maybe 180? Okay, alright, Mr. Chris. Alright, so the rule tells us that if I have a point, right, and I have an angle, say angle A, and I have another angle B, the rule says that A plus B is going to give me 180 degrees.